Today, we will be learning about the median and angle bisector of a triangle. Chapter 10. Understand the concept of the angle bisector and median of a triangle. Welcome to Meet Triangles Part 3, and the single learning goal for today is understand the concept of the angle bisector and the median of a triangle and grasp its properties, and use tools accurately to draw the angle bisector and the median of a triangle. So here is a triangular cake. What should you do if two brothers wanted to divide it equally? Let's solve this problem together in this lesson. The median of a triangle. The median of a triangle is the line segment that connects a vertex, and we could take, say, vertex A here, point A, to the midpoint of its opposite side. So the side point A, or vertex A, shall we say, in this triangle, is facing is line segment BC, or side A, and halfway in BC is point E. Point E is halfway in between B and C, so that line segment that connects vertex A to the midpoint of its opposite side, which is E, is called the median of the triangle. And let me actually say this. It's not called the median of the triangle. It's called a median of a triangle because it also works for point vertex C. Can come say about here, and vertex B. This isn't really accurate in my drawing, as you can see, but this is just trying to tell you that there isn't just one median of a triangle. There are multiple medians. Discussions. Draw an acute triangle on a piece of paper and determine its medians. What method do you have to determine the medians? How many medians does it have? What is a positional relationship? Well, after you draw your acute triangle and draw all the medians, you see that there are 3 medians, and somehow they all intersect at one point. What about the medians of obtuse triangles and right triangles? Do anything and then discuss the medians of obtuse triangles and right triangles. A right triangle's medians look like this. And the obtuse triangle's medians look like this. Idea summary. The 3 medians of a triangle intersect at one point, and this intersection is called the centroid of the triangle. So what I want you to do is quickly write down the definition of what is a median. What is a centroid? And draw any other note and write down any other notes that you think might be helpful for you to memorize this concept after this lesson. All done? Great, let's move on. So let's do one example. In triangle ABC, AC is equal to 5 centimeters. AD is a median of triangle ABC. If the perimeter of triangle ABD is 2 centimeters longer than the perimeter of triangle ADC, then BA is equal to blank. All done? Let's look at the solution together. Here's a quick reminder as you do the problem. Convert the difference between the perimeter of triangle ABD and triangle ADC into the differences of side lengths. And the answer is 7 centimeters. So there's a triangle ABC. Let me use a lighter color. Triangle ABC. This isn't very good, but I think you get the idea here. And this is point A, B, and C. AC is 5 centimeters. And I'm going to omit centimeters for now. AD is the median of triangle ABC. Here. So AD. If the perimeter of triangle ABD is 2 centimeters longer than the perimeter of ADC, then BA is equal to blank. Well, how we got this answer, 7 centimeters, is we know over here that this AD line segment right here, we can think of these two areas as two separate but smaller triangles. They share one same side, AD, but AD's lengths never change for both of these triangles. So we know that AD, they share the same line segment, which means that at least one of their sides right now is the same length. Next, we know that AD, well, we know it is the median of triangle ABC. And that median, it's what is the definition of a median? It's one point, or vertex in this case A, and the line segment connecting A to the midpoint of its opposite side, BC. That would mean that D is the midpoint of B and C. That would also mean that BD is equal to DC. So then we know that AD for both of the triangles is equal. BD and DC are equal. And so all those line segments are equal. But if we know that the perimeter of triangle ABD is 2 centimeters longer than the perimeter of ADC, what are the two line segments that we aren't sure that are equal? This AC and AB, of course. AC is 5 centimeters. So then we just have to add a 2 to that. And over here we know it's 7 centimeters. And before we move on, I want you to pause for a moment. What can this also tell us? Maybe the dimensions and the perimeters of these two smaller triangles after creating a median is not the same. But maybe are their areas the same? I want you to think about that for a moment. Now let's think about the angle bisector of a triangle. Draw a triangle arbitrarily on a piece of thin paper. Can you manage to draw the bisector of one of its inner corners? Sorry, inner corners, that is not the mathematical language. Instead of inner corners, think about interior angles. I'm just going to write angles. Interior angles. Maybe I'll add it. Interior angles. Can you get it by folding anything? Well, here's our triangle. Triangle ABC. It is the easiest to draw with a protractor, but you can also use a compass. A protractor is those semicircles with those tick marks on it. You probably know what is a protractor. And a compass, I'm thinking you might not know as well, but it's that you can search it up on Google, compass. So a compass is that thing that usually comes with you in a set of rulers, and it's used to draw circles, but of course it can also be used to make very other different stuff other than circles. But it's where you can set the distance between the 2 points and then stick one point down on a sheet of paper, and then you can kind of rotate the other point around it, and that's what you can use to make a circle. But there's many other ways we can use the compass that we will talk about later in this chapter. So that's our vertex A. Then we're going to use a compass, to, let me draw the compass right here quickly. This is the point, and it's coming here, and it's drawing this arc right here. Then we take the same radius, remember these radiuses have to be the same, and we do another one just right here on AB instead of AC. So then we mark this point where this arc and AC intersects. Then from there, we make another arc. We also mark a vertex, a point, where AB and this arc intersects. Then from there, we make another arc. And as you can see, these two arcs are going to be crossing each other. So then, this point where they intersect right here, these two arcs, and connect that with A, you will get the angle bisector of angle BAC. Now, how does this work? And one point I want you to memorize right here and notice is that, of course, these distances, well, no. So vertex A to this point right here, the radius over here, has to be the same with point A to this point right here. Then from there, what you do is you take another random length, you put it down, you set it, right? Then what you do is you take that, and from this point to here, you take this radius, this random radius, make this arc, then you take another one here. But remember, these two has to be the same radius. Then you make another arc. And remember, these radiuses has to be long enough so that those two arcs, when you draw them, can intersect. Then that point, you connect it with A. You get it. Let me quickly go through it again in case you need another explanation. So, what you do is you're trying to find the angle bisector of angle BAC. Then what you do is you take a compass, then you set it to a radius, a random radius, and then you make an arc on AB and on AC, and the center of both of those arcs is on vertex A. So from vertex A, you make these arcs, and the distance between and as you can see, one point on this arc intersects with AB, this part, and one point on this arc intersects with AC. And when you do this, you have to make sure that the distance between this intersection with AC to point A is the same as the intersection on AB to A. So these two distances from this point to A and from this point to A have to be the same. Then from those 2 points, you take another random distance, but that distance has to be long enough for these two arcs to intersect. And you take one on this point, and then you use that random distance to quickly make an arc here. Then you take that same distance, come over to this point, then you make another arc, and where those two second arcs intersect, and you connect it with A, you create a ray, which is the angle bisector of angle BAC. So here's a definition of the angle bisector of a triangle. The angle bisector of a triangle right here is AD. And there are multiple angle bisectors in a triangle, just like the median of a triangle. It is not the angle bisector of a triangle, but a angle bisector of a triangle. I want you to notice that. So now let's go back to what is the angle bisector of a triangle. Well, unlike the angle bisector of an angle bisector of a triangle is a line segment. So, and mind you, this is not the same thing as a median. An angle bisector is a line segment from one vertex, in this case A, to the opposite side it is facing, so that it creates a line segment. But that line segment has to make sure that the smaller angles BAD and DAC are equal, as shown in this figure. In a triangle, the bisector of an interior angle intersects its opposite side. The line segment between the vertex of this angle and the intersection is called the angle bisector of the triangle. Notice, the angle bisector of a triangle is a line segment. Let's do another example. As shown in the figure, in triangle ABC, angle BAC is equal to 68 degrees. Angle B is equal to 36 degrees. And AD is an angle bisector of triangle ABC. Find ADB. Now, using the knowledge we learned from the math lessons a couple of lessons ago and in this lesson, I want you to try to solve this by yourself before we go through the solution together. Okay, so let's first analyze the information we know from the problem. We know that BAC is equal to 68 degrees. We know that angle B is equal to 36 degrees. We are trying to find angle ADB. And we know that AD here is an angle bisector of the triangle, also an angle bisector of angle BAC. We know that angle, but what do we need to know in order to find this angle right here? Remember from the first lesson in chapter 10, we learned all about how the sum of the interior angles of a triangle add up to 180 degrees. Do you still remember that? So if we want to find this, all we need to find is angle BAD over here, this angle, and angle B, which we already know is 36 degrees. So we just need to find what is angle BAD. We know that angle BAC, this whole thing, is 68 degrees. And we want to find half of it since we know that line segment AD is the angle bisector of angle BAC. So then this angle right here has to be half of 68 degrees. So half of 68 degrees would be 68 divided by 2, which is equal to 34. Therefore, angle BAD is equal to 34 degrees. Now that we know that angle B is 36 degrees and angle BAD is 34 degrees, we can easily find the angle number for angle BDA or ADB. What we do then is we take 180 degrees, the total of all the interior angles, then we minus the sum of 36 plus 34 degrees. Then after we subtract, the answer would be angle ADB. So angle ADB, we do 180 degrees minus, what's 36 plus 34? It is 70, which means that the final answer for angle ADB is 110 degrees. So let's take a look at the solution. AD is the angle bisector of triangle ABC. Angle BAC is 68 degrees. So angle DAC is equal to angle BAD, which in both of them is 34 degrees. So in triangle ABD, angle B plus angle ADB plus angle BAD is equal to 180 degrees. Angle ADB is equal to 180 degrees minus angle B minus angle BAD, which is equal to 180 degrees minus 36 minus 34, which is equal to 110 degrees. So notice in this solution, the person who was doing this problem in the solution was, at first, he immediately wrote down that angle DAC and angle BAD was equal to 34 degrees. That's what I want you to be able to do too. I want you to be told that this whole angle is 60 degrees, and we know that this line segment over here is the angle bisector of it. So then it should immediately come to you that first, both of these small angles are the equal and the exact degree of each of these small angles. So here's the class summary. We learned the several important line segments in a triangle. Median, the line segment connecting the vertex of a triangle to the midpoint of the opposite side. An angle bisector, the line segment that bisects the inner angle and intersects the opposite side of the triangle. So did you write all of these important points down? Remember, the angle bisector of a triangle is a line segment, not a ray. And the lesson summary for today is understand the concept of the angle bisector and sorry, this isn't supposed to be midline. I don't know why. So this is not midline, it's median of a triangle. Grasp its properties and use tools to accurately draw the angle bisector and median of a triangle. So I hope you enjoyed this lesson, and I'll see you next time.